Redis is a key value store, but real-world data is rarely just one value per thing. Hashes let you group multiple field value pairs under a single key, turning a flat string into a structured object. A hash has 3 layers: the key, which is the parent identifier, the field, which is the sublabel, and the value, which is the data itself. HSET stores these pairs, and every field acts like a miniature key value pair nested inside the parent. When you store a user across many top-level keys like user 1, name, user 1, age, and user 1, email, every key carries its own metadata overhead. A hash collapses them into one parent key with fields, and when values are small, Redis uses a compressed list pack encoding that dramatically reduces memory consumption. Retrieving a full user profile from a hash takes a single key lookup. With dozens of flat keys, you are stuck making dozens of round trips. TTL and persistence are also cleaner. Set expiry once on the parent key and the whole profile ages out atomically. Hashes are perfect for user profiles, session storage, shopping cart line items, object caching, and configuration records. Anywhere you are modeling a single entity with several attributes. Redis ships a full command kit for hashes. HSET to write, HGET to read one field, HGETALL to dump everything, HKEYS and vals to list fields or values, HDL to remove fields, increby to atomically increment numeric fields, and HexES to check if a field exists. Hashes are not for everything. Skip them for very large values that exceed the list pack threshold, for deeply nested structures where you need real querying. Serialize to JSON instead, and when you need ordering or uniqueness, reach for lists or sets. That is the hash in one breath, one key, many fields, dramatically less memory, and a natural fit for object-shaped data. Reach for it whenever a thing in your domain has named attributes that belong together. We open a fresh terminal session on Ubuntu and issue the classic clear command to wipe the screen, giving us a clean workspace before our Redis demonstration. Clearing the terminal before a sequence of related commands keeps the output uncluttered and easy to follow. First, we verify Redis is reachable by sending ping through redis-cli, the official command line client. The reply pong is Redis' canonical way of confirming it is alive and accepting commands on the default port. If this returned an error, we'd know to start the service before proceeding. Now we create a hash named user 1001 using HSET, passing 3 field value pairs in a single command: name, role, and level. A hash in Redis is a single key that maps multiple fields to values, much like a row in a database table or a dictionary in code. And HSET returns the count of newly added fields. To confirm the hash exists and inspect its structure, we run type on the key, which returns hash, Redis internal data type designation. This proves that user 1001 is not a string, list, or set, but specifically a hash container holding our 3 fields. HGET retrieves a single field by name, returning just the value associated with name. This is the fastest way to read one specific attribute without pulling the entire hash back to the client. HGETALL fetches every field value pair in the hash at once, listing them in flat field then value order. This view proves the single key user 1001 holds all 3 attributes together, which is exactly what makes hashes so useful for structured records. Keys with the pattern user asterisk lists every key in the database that matches, and we see only user 1001 returned. In production you'd use scan instead, but for a small dataset this gives a clear snapshot showing our single hash key among the wider key space. Finally, DEL user 1001 removes the entire hash in one shot. All 3 fields vanish together because they belong to the same key. DEL returns the count of keys deleted, and a follow-up keys user asterisk confirms the key space is empty again.